Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. I'm going to do a quick tabletop exercise for you today just to kind of answer some questions that came up about my last video. Now, yesterday I put out a video where I demonstrated how to find your position on Earth based on a sextant reading from two different stars. Now, there was some confusion about how I did that, so I thought I would just have a quick tabletop exercise to show you how that's done. So today what we're going to have is we're going to look at the star Vega. And we have three values here that are essential to find the geographic position of the star. The first one is called the Greenwich hour angle to Aries. The second is called the Sidereal hour angle. And the last is called the declination. Now there was a little bit of confusion about this, so let's go ahead and see if we can make this a little clearer. If you look at the Earth from the viewpoint of the North Pole, we're going to have a couple of prime meridians. The first one is going to be the prime meridian of Greenwich, and that is 0 degrees longitude. And then out in the celestial sphere, which is out here, we're going to see Aries. And if you want to try and figure out what Aries is it's the point on the celestial sphere that is directly over the equator at the March equinox. And that is the prime meridian of the celestial sphere, so to say. So let's look at a situation right here where Aries is directly over the prime meridian of Greenwich. In that case, the Greenwich hour angle to Aries would be 0. Now, as the Earth rotates, 2 hours later, we're going to be 30 degrees to the east. Our Greenwich hour angle to Aries will no longer be 0. Our Greenwich hour angle to Aries will now be 30 degrees. Likewise, if we wait another 2 hours, it'll be 60 degrees. What that does is that orients the Earth to the celestial sphere. So it gives you the relationship between the prime meridian on Earth, the meridian of Greenwich, and Aries, which is the prime meridian of the celestial sphere. Now what this means is that at this time, if the Greenwich hour angle to Aries is 30 degrees, that means that Aries will be above the 30-degree west line of longitude. See how that works out? So now that we understand exactly what the Greenwich hours of Aries means, we're going to look at another star right here. Now, if we look at an angle from the center of the Earth to Aries and then out to a star, say we have an angle of 40 degrees. That's called the sidereal angle hour of that star. Now, in order to find where that is located over the Earth, what we need to do is we need to figure out what the Greenwich hour to Aries is, and then we need to add to it the sidereal hour angle of the star. So we have to figure out how far it is from Greenwich to Aries, and then we need to know how far it is from Aries out to the star. So the Greenwich hour angle equals the Greenwich hour angle of Aries plus the sidereal hour angle of the star. Does that make some sense to everybody now? Now, what the Greenwich hour angle will be is that is the longitude of the geographic position of the star now. The sidereal hour angle between Aries and the star does not change. The Greenwich hour angle to Aries does change as the Earth rotates. So now that we have the longitude of the geographic position of the star, we need to get the latitude of it. So let's look at the situation up here that we find ourselves in with Vega. Now, the sidereal hour angle of Vega is 80 degrees, 35.3 minutes. So if you look at Aries, down to the center of the Earth, out to Vega, this is going to be 80 degrees, 35.3 minutes. Now, the next thing that we have to figure out, where is the Greenwich prime meridian in relationship to Vega? Well, as it turns out, the Greenwich prime meridian is over here. And this is 184 degrees, 0.6 minutes. So what is the Greenwich hour angle of the star Vega? Well, it's 184.06 plus 80, 35.3. So if we add those together, we'll get 264 degrees, and we're going to get 35.9 minutes. Because what we do is we add this to this. There's a slight difference when it comes to dealing with longitude and dealing with the Greenwich hour angle. Now, when you're dealing with longitude, you start at a prime meridian of 0, you go all the way east to 180, and you go all the way west to 180. So there are no lines of longitude that are greater than 180 degrees or less than 0 degrees. Now, the Greenwich hour angle works a little differently than this. There are 360 degrees in the Greenwich hour angle. However, unlike this split situation where you have an east longitude and a west longitude, what happens with the Greenwich hour angle is you start off at 0 with the prime meridian. And then an hour later, the Earth has rotated 15 degrees. So you go to 15. Likewise, you go to 30, 45, and work your way all the way around to 180. Then what happens is you continue to work your way around until you get back to 360 and 0 again. So there's no split like this, east and west. It's going westward from Greenwich, 360 degrees throughout the entire rotational period of the Earth. So where would this longitude be? Obviously, this is greater than 180 degrees. So as we've come around, we've gone through the entire western hemisphere. At 180 degrees, we enter into the eastern hemisphere. Now, yesterday what I talked about was taking 180 away from this, and that would give us the amount of distance that we're in to the eastern hemisphere. There's actually a better way of doing this. I wanted to go through that to give you some clarity, and now I'm going to teach you the shortcut that you need to know. If you take 264 degrees 35.9 minutes and subtract it from 359 degrees 60 minutes, you're going to get the longitude in the eastern hemisphere. So 264, 35.9. 95 degrees, 24.1 minutes east longitude. The reason we use 359 degrees, 60 minutes, which is 360 degrees, of course, is to just take care of the minutes on the number that we're subtracting from. Just makes it work out easier. So that would be our east longitude. Here would be our latitude, and that's north latitude. That is the geographic position of our star. Now, in our next episode, we're going to go over the astrolabes. In our first episode, we're going to have an introduction to what the astrolabe is and the different parts of it. And then we're going to start taking some measurements of the sun and the stars. And then we're going to learn how the astrolabe will teach us how to tell local and solar time. And we're going to learn about the equation of time and time corrections. So until then, this is Bob the Science Guy. Thank you very much for stopping in. And remember, hit that like and subscribe. And I'd like to see you as a member of our channel. Take care, guys.
This rabbit hole falls too deep.